Hello there, welcome back. Today we're going to be doing some iteration on the pings that we started the other day. So let's take a look at where we got to. You can ping, you can actually hold it down right now, so let's go fix that. This should be the first thing that we fix. So we have some core player character here. Should have an input. Currently it's on triggered and we'd want it to be on started. So let's hit play, see that. Yeah, so now holding down my middle mouse button doesn't constantly place them, but we can place infinite of them, so we do need to track them in some way. We need to have a maximum count. We need that to be defined somewhere, and so for now, for simplicity, I'm going to track that all inside the GA ping system, which is held through a gameplay ability right now. So let's just do max pings. We're get some consistency here in the naming. Okay, so max pings, let's go with 3. And anytime that we execute the ping trace, we're going to create a ping actor here. When we create a ping actor, let's track them and remove the last one. So current pings, turn this into an array. We can crash the engine. No? Okay. How would we do this? We could promote this to a local variable for now. So L ping. And then we would ask if the length of this is more than the max pings. Which apparently I've done as an int64, which is not what I wanted. What we could do is we could add the unique ping. Actually, we could just add the unique ping immediately. We don't need to store a local variable. And then we can ask if the length is too long and go and end the life of the first ping. So let's have a look in here. If it's more than the maximum pings, then we should get element 0, which will be the oldest one, and destroy that actor. This is all happening on the server, so should be good. Now, one thing that we want to do as well is bind to just the event for destroyed for any of these pings and create a custom event. We'll do a matching function on ping actor destroyed, because we would want to remove that element from the tracked array so that we're not tracking out of date pings. Let's cast this to a ping actor. Okay, so that'll just be a little bit of code cleanup there. So this is going to be for our max pings, which is what we're doing right now. Okay. Moving forward, compile this. Make sure that this event is hooked up. And let's see if that is doing what we expect. 1, 2, 3, 4, 5, 6, 7. So you can only ever have 3 of these at a time. So that's looking awesome. Max pings sorted. Screen edge logic. So we've currently got these pings attached to an actor, which is actually not going to serve us for clamping anything to the edge of the screen. So we're going to need to change how that is done. So we'll need a ping manager, and we'll need some functions. Registering a ping, unregistering a ping. We can have these, I believe the best way to do this in this case is going to be through a component. So let's create one more component, just the ping component, and this is what's going to hold the data. So in here, we'll add ping component. Do the same in the unregister. And then we'll track an array of those. In our register ping, we're going to want to add one of these. We'll have some delegates off of here. On ping added and on ping removed. Call those. So when we register a ping, we'll call that we've added a ping comp to the manager. And whenever we unregister a ping, let's say that we removed a ping. And the whole idea of this bit of code is so that we can listen to this in a panel that we'll create that will manage our pings instead of being through an actor. So we have our ping component here. We can delete the functions that we've added. The only thing that this ping component is going to need, I would say, is knowledge of what it looks like. So when you spawn an actor with a component, we will tell it what to look like. So get rid of all this code, and we can go and check out. Got our pings going on here. We're going to destroy these actors. Let's at least create our panel that we need in order to represent these pings. So in this UI here, we're going to need a user interface widget blueprint. And this is going to be our widget underscore ping panel. What this does is it will get the owning player, which is as a player controller. We should be able to get their HUD, get a component by class, which is going to be our ping manager. Going to assign to those pings being added and removed, and that's how we're going to track them inside the UI. So ping assigned for a ping removed. On construction. Get rid of everything else. And so listen to manager events and draw / remove ping UI from panel. So this panel will be a canvas panel. Make sure that that's visible. Canvas panel for the pings. We're going to add child to this. Actually, we'll add it to canvas. Add child to canvas. We're going to create a widget. Oh. Let's get these sorted. So let's convert these into functions. Collapse to function, collapse to function. In our event graph, we can actually call those events like so. Create event, get rid of these. This one is going to be, oh, apparently it didn't work. Let's try again. On ping added and on ping removed. Back in our event graph, we should be able to pick those now, on ping added and on ping removed. So that's our two manager events sorted. We could actually move this into a collapse function. Oh, I can't do it. It's because these are written in an assign. So if you use the assign, you can't collapse the function afterwards. It doesn't like it. So you have to use the bind event. It's basically the same thing, but just a little caveat of Unreal. I'm going to hook these up. Ping added, ping removed. what I'm going to do is put all of this into its own function that's just initializing the ping manager. Init ping panel, I guess. And that's going to potentially do something else in the future as we're initializing, but we'll hold it like that for now. Okay, so when we've added a ping, we want to get some data from this component, which in this case is going to be the data asset. So this ping data. And so we've already made some ping data. We made a basic ping. It's got a look set and a widget that it will want to use. And I believe these are soft references so that we're not loading them at runtime yet. So we're going to have to load these as they come into being. Now, I think that's mostly reasonable. So now we have this data asset on here. In our ping panel, we can get that data asset and we can get our widget class from it, and then we can draw that. Now the issue with this now is that we would want to asynchronously load this, which is obviously a problem because, well, because it is not set up as a function. It's not capable of doing async calls. So you can't async load from here, but you can block load. We don't really want to do this because it's going to cause hitches when there's other loads, when there's other asynchronous loads happening in the game. Could be literally anything, and then you call this blocking load. It's going to purge all of those asynchronous loads, and it's going to cause a hitch. And so we need to manage this in a way that's a little bit nicer. Okay, so how would we do this? We would want a custom event load next ping data. Is there a better way of doing this? I guess one thing to consider is that if you have a reference to these pings, they are the wheel of pings that exist on some actor in the world, and they are therefore somewhat relevant. So I might actually just make this a hard reference for the widget class here, because we can say that that should be loaded. I think that that's reasonable. Otherwise, we have these material and texture options for how the ping is displayed. So we init the ping panel, and we add this ping. We're going to create a widget here. Okay. So the only player, I mean, it's going to default. It's going to default to us anyway. And then we will add this to the panel. So add child to canvas panel here. And then so from here we can set alignment, which in this case we're going to use 0.5, 0.5. So center aligned as we move it around the canvas panel. It's going to add it to 0, 0 top left of the screen to start with. So we're going to want to at least get a function in here that's get widget position. Sure. And that will, of course, take a user widget. Just call it widget. How do I want to track this? So we've got the ping that's been added. We've got a ping component. That is how we're going to find the world position. So we should be tracking this promoter variable pings. And we should probably consider caching this actually as a key map. So it'll be the ping component to the ping widget, widget underscore master. Add to this. So now we have a relationship with this key map. We can say that the ping component represents a particular widget. And that will allow us to manage those a lot easier. I will actually add that here. Okay. The reason we're doing it this way in a ping panel and we're coding all of the position logic inside the ping panel is so that we only have one tick that runs, and it's easy to debug, it's easy to manage and consider cost. Whereas if we do the tick in every single widget, then we have to pay the cost for that. A little more distributed cost at that point because there's multiple ticks happening. So we've got this ping, we've moved it here, we're going to get a widget position. This is going to be a pure function that outputs a 2D vector, which is a position on screen. And it's going to take a component. So it's going to take one of the ping comps as the location to derive the location from. And so in this case, we're going to use this ping component, and then we're going to set this widget slot as canvas slot, set position. And this is the same. The reason I'm splitting this out into a lot of functions is because I know I'm going to be reusing them. So this is exactly the same functionality that we'll use in update ping positions. We'll take this key map, we'll get the keys, which are the ping components, and for each of those, we may want to validate here, because it could be the case that we're partway through a loop and one gets destroyed. So as we do this, we can actually promote this to a local variable, L ping comp, and that's the ping that we're going to manage for the rest of the loop. So what we can do is we can find the related widget to this local ping component within the loop. And that'll be our widget that we're updating the position of. And this lping component is where we're going to get the position information from. So it'll be world position to screen position. So now we just need to code this, and then we should be good to go. So this is where all the clamping logic is going to happen. Okay, where are we so far? Ping component. This ping component, I'm actually going to add it as currently it's an actor component. I actually want it to be a scene component so I can control the position a little bit better. So I'm going to reparent this to a scene component. Compile that, save all. What I can do now is get world location, and I can get the player controller. I can do screen to project world to screen here. Take this ping comp. For now, we'll just use this property to determine that. Okay, so back in our gameplay ability system for our ping, when we create a ping right now, we create this ping actor. And at the moment, we're using this widget. So what we need to do is we might retain our old logic because it is called deprecated widget component method. So that's what we built in the last stream. And because I changed this to a hard reference class, I don't need to load it like so. Just put all of this together. So that's the old method. We're not going to call that anymore. Instead, what we'll do is we'll add a ping component to this and a function for, in fact, we won't even need a function because we've already got the ping data here. It's already exposed. Set ping component data. Set data asset. In fact, we don't even need to input this like so. In fact, we could. This is a notify. Why is this a notify? What happens on notify? On rep ping notify, draw the widget. Okay. Maybe we just need to change convert event to function. Move this down. Deprecated widget component method. Put that out of the way. When we want to draw the widget of this ping component, let's figure out what we're doing here. The data asset has been replicated. So we want to get the ping component, we want to set the data asset on it to be this data. It's replicated via the actor itself. That seems reasonable. Okay, so now that we've done this, once this data gets set on the ping component, we actually want to send it over to the manager. So let's actually get a function for that. Set data asset here. Then get player controller. Get HUD. Get comp by class. Ping manager. Register a ping, which in this case is self. So we're going to register, once we've got the right data from the replicated actor, we can actually push that to the manager. And what we can do on this asset as well is event destroyed or event end play. We can do the reverse for this. So we'll actually turn these into functions. Register. Register ping with manager, and then we'll do unregister and register ping with manager. Do unregister ping self. Sorted. Okay, so whole bunch of blueprint code right now. We're going to get into some animations soon, hopefully. I'm going to use the Niagara particle system to draw some cool effects for when a ping lands. Okay, so a blueprint ping draws. We're going to set the data asset on the ping component, which is a function that contains some additional logic, which means in order to keep things clean, I want to actually privatize this data asset and have a get data asset function that actually outputs this, because that's going to be a lot cleaner for other blueprints. They don't accidentally set the data asset directly. There's only one way you can set the data asset. It's just a nice little bit of code management. Okay, cool. So we unwrap the data, we draw the widget, which means that we set in this case, we set the data asset informs the manager. In fact, we could change this. We could just be like, hey, let's rename this to configure 3D widget. And on rep, we're no longer going to configure 3D widget. Instead, we're going to set the data asset on this asset. Okay, cool. And then we register it with the ping manager. That registers, that runs through. It becomes a ping that's tracked and has a delegate. And then our ping panel, which on construct will initialize and listen to these events. The other thing that this needs to do is it needs to get pings. And for each of these, it needs to run the on ping added function so that as this data or as this event runs, if there's already some pings inside the manager, we will need to draw them. That will be important. So we'll make sure that we do that as well. Okay. And now we have, yep. So I did change that because that was going to make this pure so it's cleaner in the graph. It's just returning a variable, so naturally, in order to ensure that this doesn't do anything else, we can actually make this const as well. Okay, so we've got everything hooked up, I think. The only thing we need to do now is in our core, we have a HUD here. We're going to need to create widget. It's just a quick way of doing this. And we'll just draw the ping panel to the screen. Add to viewport. And so for now, I actually don't know how well this will work without a little bit of debugging. So as we middle click, we are missing a few things. First, let's make sure that this HUD calls its parent. And let's make sure that it's being reached in the code. So it's not being reached in the code, which means that this HUD class is actually not the one being used in our game mode. So if we come here, we've got the LPSP HUD. We want the Yuxif version. Hit play. Now we're actually drawing the ping panel. We can actually start debugging other locations. So let's go and check out our gameplay ability that does a ping. It takes in a ping data. And we already tested this. This is the first thing we did on stream today. So this does get created back in the event graph for the ping actor, which surprisingly I do not have here. That's the data for the ping. That's the panel for the ping. I'm going to rename this to ping actor. One thing to be aware of when you rename things like this is you want to look at the other filters, show redirectors, and I'm just going to run and update redirectors on the root folder anyway. Okay, so we've got that ping actor. It has a ping component. It exists at the center of it. Just double check that this is being reached, which is not. And I think the reason for that, we never finished the end play. Event begin play. So the end play for the ping component will unregister it from the manager. That's fine. There's some sort of condition going on here where, yeah, we've got this configure for 3D widget. Let's collapse this. Update ping component. And we'll actually call this on begin play because my expectation is that this ping data is already replicated by the time that that it exists in game. So bam. Okay, so now we have this asset, but we're not obviously its size is wrong and its position is wrong. The reason that we're converting this from a widget component into something on a HUD layer is so that we can control the position, clamp it to the edges of the screen, and then start adding an arrow and do some cool stuff with it. As a widget component on an actor, it's not very easy to control. It's very quick to set up, but it does just move off screen, and that's not great for our what we want to build. So for our goals, okay, so looking at the list here, we've got the ping screen logic. Starting that task meant that we needed to convert this over to UI rather than being a 3D widget component. So let's continue the workload. So we have all of this foundation in place now such that we end up with the ping panel being updated with a ping. Let's finish off on ping removed. So for this, what we can do is we can go and find the ping component and remove from parent. And then we would also remove the entry in the key map. So this is a key map that we're storing inside the ping panel that maps a ping component to a ping widget. It just gives us a really simple control for that. A simple way to store that data. Okay, so now we do want to tick this panel because we need to update the ping positions. And what that's going to do is it's going to go through all of our pings, get the ping component, find the widget, update the widget's position, like so. And this get widget position function is where we're going to clamp the position to the edge of screen space. And we could do that as the true edges, or we could do it as an oval, and we might investigate both, depending on time. So we're half an hour in right now, and we're going to, next up, ensure that our onPing added event is actually configuring the size of the widget as well. Because right now, this is not the correct size. We noticed it was like kind of flattened. So let's just run that and fix that first bug. Bam. So now, oh, it's actually already working. So would you look at that? To some degree. So the problem right now is when, well, you can see how it's kind of dragging strangely. And the reason for that, and the real simple way that we can go and debug this now, wish I had a mute button. A really simple way, because we've written all this in a nice way. We know it's the widget position that's a problem. So what we need to do, let's try this. Well, this is for split screen, so we're not going to worry about that right now. I suppose we could. But one thing that's happening here is this is coming out as screen space position, but not relative to the actual view that we're looking through. So let's do world screen again. We've got project world to screen, and we've got convert world location to screen location. Let's try this other one and just see if there is a fundamental difference. Nope. So all we've got to do though, this is just by knowledge, is multiply this by the view scale. Or maybe it's divided by the view scale. There you go. So now they're actually persisting as well, which they didn't used to. They used to remove from viewport when they were off screen like this. So this is cool. We type edge screen. There is a helper function for actually getting the position clamped to the edge of the screen. I'm just going to go and check online. Just do a quick Google. Might only be in Lyra, which is annoying. There is definitely a function for this. I just can't remember what it is. I wonder if this function that I've just found as well is going to do this math that I've added. So let's just try that quick. It does. That's very good. Awesome. So we don't need to do this math now because we actually have get world location to widget position. I swear there used to be if a helper function for this UE5. Um, the reason I recall something while I'm working on this is because when it was at the edges of the screen, it would it would basically sit in the top left sometimes and just stay there. Um, and you had to manually fix that. I might be remembering something from a later version of Unreal, to be honest. The simplest thing we can do is clamp this at least. So we would clamp float on both of these. We would get the view size and we would divide that by the view scale. Okay, view scale. So we would say that this widget can never go below 0 on either end, top left, top or left, and it can never go beyond this X and this Y. And then we would just recreate that vector 2D. Let's see how that does. Yep, so you can see now it's actually sticking to the edges of the screen. And the only thing that we would want to do as well is either manually define a padding that we would add to this, or we would define, say, like through cache geometry. So we could actually just get cache geometry, get size. We'll get the local size, I suppose. And then we would want to define like additional padding. So let's just say padding, um, edge padding. And we'll do that as a vector 2D. For this local size, what we want to do is divide that by 2, convert this to a float, and then we would add the extra padding to that. So if it's a 50 unit element, we would natively pad it by 25 units. If it was 50 units wide, right, we would pad it by 25 and now it would always be on screen. If then we add the extra padding, say it's just another 10, and that's the value that we come up with. So you can break this. We can use this as our 0, and then we can multiply this by -1. Break that, and we would add these together. So this is our negative. So if you imagine x is 1920 wide, we're going to now minus, because this is -1, right? In fact, we could just say, yeah, let's just make this cleaner. Minus x minus y. And this goes into our max, right? Let's try and clean this up as best we can, because it is pretty messy. Edge of screen with padding. And so for now, I haven't added any padding. So it's like perfectly in the center of the screen. Wonderful. What have I done? X minus... oh, I've minused half the size of the panel, not half the size of the widget itself. So I'm going to need, when we're updating positions, we're getting this widget position, I'm actually going to need this widget reference in order to get the cached size, right? So we'll say ping widget. Plug that in. We actually have this in two positions. We have it on the added as well. So we're going to need to plug this in here. Okay. So now that we have that ping widget, that is the widget whose cached geometry we're going to use to determine the local size of that widget. That was the intention. I just did it wrong. Okay. And then a bunch of math. So should be good to go. Hit play. Okay, so it goes to the edge, and I haven't added any extra padding right now, so we just have a widget. And like I said, you can see here how it's sticking to the top left of the screen there. So you can do some things around your rotation. When it's behind you, you could use your rotation to slide that across the top, and it looks a little bit better. But first I'm going to add some extra padding. So I added a padding function here. I'm just going to use 50 units. Okay, so now that stays on screen nicely. Basically, I'm prompted in which direction to look. So the problem when it's behind you is it's always that back corner, right? Which is super annoying. So what I'm going to do is take a screenshot of my screen padding. So I'm going to post that into ChatGPT. This works until it's behind me and then it's stuck in the top left corner. And so I would like to resolve that. I don't like that we've got three pings. They move around with our screen, but they get clamped to the top left when the asset is behind us. And so I would do a branch of some kind that basically says, is it behind us? And if it's not, then we'll just use we will use this position. And if it is behind us, which we'll code here, then we need to do then we need to do some other logic. So first, let's get our owning player camera manager forward vector. Dot product that with the direction from where this pin component is to that camera. Actually, it's doing the same thing that I'm doing. Obviously, I've done this before, so a long time ago, but I have done this before. So all just nodes. So have a look. We got the world location. Okay. So we get that dot product. Awesome. And just to speed my process up, I'm going to check which way around that needs to actually be. Get direction to the target. Yep. Just print this. Okay. Well, I can't see where it is now. There. Let's just return that. Ah, okay, so this is minus, this is 1, so I am doing it the wrong way around. So either I'm doing this unit direction vector the wrong way around, or I'm doing my dot product the wrong way around. Let's try flipping these first. That seems reasonable. We're getting the unit direction vector from my camera to the asset and asking how close that is to my camera's forward. That seems, yeah, I mean, I could have figured that out if I just read what I was writing. But dot products are always fun to work with, so trial and error tends to be quicker. Flip the projected position when behind. Okay, so we have this variable and we can say, hey, this is less than 0, which is going to be our is behind. Apparently, GPT reckons that all I have to do is flip this, or at least it's saying take this minus the screen center, which is in this case probably this divided by 2. It's saying minus. I don't know where it's getting this logic from, so this might be completely, absolute rubbish. But I'm going to trust it for a second because it's interesting. It might be the case that this actually outputs as -1. So let's try printing print string and just try and print this. Because if it's not changing when it's behind us, there's no point. Yeah, I mean, it's not changing. So minusing the screen center. not really going to do anything. So what I tend to do is I take that direction dot product and I turn it into an ACOS angle. And I say whatever that angle is going to be my X from left to right. And then I just choose whether I want it to appear at the top of the screen or the bottom of the screen. Here, yeah, okay. So this bool success is the one that actually tells us if it's failing and is stuck to the top left. So that I do recall that actually. That's pretty cool. It's been a while. Bam. It's funny that did that the wrong way around. Here, let's go L success. L success. If it's successful, we want to do this. And if it's not successful, then we don't want to use this variable at least at all. But we will still care about the clamping at some point. So we could actually convert this into a little function. The way I like to do that is I'll put these little reroots in, and then I'll grab everything else that I want, which in this case is the local size. Collapse this into a function called getClampedPosition. This will be pure. And I could change this to X, Y. Oh, I accidentally took the geometry rather than the size, which was incorrect. Cut that and change this into size, widget size, vector 2D. That could go in there. And then we can just say X, Y, the widget size. Trying to clean this up nicely. It's a little bit of a pain. That will be sufficient. Okay. And then this I should really just also say position, and then we have vector 2D. Vector 2D, please. That one. Put this up by one. Whoops. Get position. Break. And plug those in here instead. Okay, ping added. Update ping position, that's fine. This we could just plug straight in. Awesome. And so now because this is a clamped position, I can actually still call this down here when we figure out what position we kind of want it to be on screen, and then clamp it afterwards. So we still have that function going for us, which is good. And we have this dot product, which we might actually use for rotation. Let's have a look at what GPT is giving me here. It might actually have some interesting solution. that I haven't tried before. It okay. Here's what it's saying. Project world location to screen is failing, giving you 0, 0. So you clamp graph happily clamps the corner because it's a legit position. You need a special case for behind the camera. If the point can't be projected and the value is false, then fix by mirroring the point in front of the camera when it's behind. Do this before the edge of screen with padding pat in your screenshot. Get the camera's location and forward vector and get the vector to the target. So the target location is your actor or ping world location. That's the target location is the ping's location. And you basically take that target position, you minus the camera's position from it, which I'm assuming throws the position in front of you. Then it's saying that you get the vector length to that new target and the direction to that target. Dot product from your camera in that direction. That's interesting. So I would take the world location of this and minus the camera's position. I don't know if this is going to work when it's. Oh, we'll see. We'll see. It makes somewhat sense because essentially you're saying it's somewhere over there. So how about I just say flip that and put it equally opposite direction. Then it would be at the top of the screen. Well, we'll see what happens because from there I can at least then do. I can project off of that basically, as far as I can tell. Because I could then do this. Do, but I could do this. Apparently. What's this? This is my camera. I'm going to take a screenshot of this and just get it to review to see if I'm actually doing what it is suggesting or if I've misunderstood it. So I'll show you the GPTs. So yeah, this is what's going on. I really like this tool sometimes. It reckons that this is correct. So what happens? It's in front of me, that's all good. As soon as it's behind me, no, it's still behind me, game. Why? Let's have a look at the logic that I wrote. I wish I could take a higher res screenshot of this graph. That I think there is actually a way of doing it, but I've forgotten. had an issue where basically ending play in editor or quitting, presumably quitting the game, would trigger an issue. Um, but we should always actually just defensively say, like, is this player actually valid? Because if not, canon register it. Okay, so it's telling me that I actually wrote the conversion wrong here. So we want ping world location minus camera location, ping world location minus camera location, and then camera location minus that. And then camera location plus this is getting silly. And camera location plus this multiplied by -1. It has become a coding stream. I didn't get to do art again. So there's -1. And it says 2 multiplied by just reading world location. Okay, so apparently this is now mirrored in front. What? Would you look at that? Yep, cool. Now, all I'd want to do is make sure it's at the top or the bottom of the screen. Okay, so yeah, so now I just want to make sure that that position that I've hacked together there is actually a lot cleaner than other times I've done this, thanks to GPT existing now. And every other time I've had to do this has been just me and math. Although I would say that some of my old math was pretty elegant. In particular, the one that just converts the angle to the position. But anyway, we kind of have that now. We're clamping the position so that we don't go out of the bounds, but we actually want to push this to the edges. I'm just going to make sure that the plugins are installed for the Niagara UI. That is what I want to do today. Apparently, it isn't. I'm going to go get that installed. Go library. Niagara. Huh. Seriously? So what GPT said now. So we have GPT saying that you should shoot a ray from the screen center forward to the projected point and find where it hits the screen rectangle. Hmm. Yeah, the math's a bit wild. Math's a bit wild. I'm not sure I'm a massive fan of that math. I'm going to ask it one more time just in case I wasn't very clear the first time. Um, so how could I take this? I could I'm going to try something else. I am going to try what I did some time ago. So we can find the lookup rotation between my camera's position and the ping's world location. And that will give me, well, we can print it. Let's print it first. So it's going to give me several rotation options. Yaw and pitch basically is what I'm hoping for. So damn it, I did two and I only want the data once. Okay, actually, and also this needs to be like this. Okay, so hit play. Now if I turn, once it's behind me, you can see pitch. And I can use this pitch from 0.5. Oh, it's 0. That's interesting. Should be roll pitch yaw, but it's pitch yaw roll. Anyway, the yaw, annoyingly, it's just like, hey, it's minus 90. Did I do something wrong here? I expected the yaw to basically be nice to me, but apparently not. What I want to do is construct an XY that I'm then going to push into the make here. I'm going to push in to this clamp. I'm going to construct it from wherever I have some math over here for this. Let's get rid of this multiply by 2. Okay. Construct it from this. It's going to be from 0. In this case, it's going to be from 0 to max y, max x, and max y here. And then these values, I'm going to try something from the dot product. Yeah, we'd like to think it's something like minus 90, 60, 60. Okay, and then so step 1, get the yaw and pitch differences, get the camera rotation. Sure. Normalize axis. I've never used this before. Angle. It's going to be direction is the maybe something like this. All right. How far are we in now? Wow, 1 hour and 16. Wow, the last 45 minutes literally doing this screen edge clamp have flown by, which gives me 45 minutes left. And I would really like to add sort of like appearance animations and then removal animations. It's asking me to do something that just doesn't make sense. It's like I just turn the vector into a rotator. I'm like, huh? Rotation from X vector. I know what that is. I think these two are ostensibly the same. Then it says, just break this, take the yaw, the direction, and then just take the camera's rotation. Break. And then minus this yaw. Apparently this normalized axis is going to give me a delta. The delta that I'm looking for. X, Y. We're about to find out. Go behind. Okay, so up and down. Okay, very cool. Left and if I get to the bottom. It's only ever sticking to the left and right. That is kind of cool though. And so one thing I don't like is you see how it jumps, like boop, it just jumps all the way up there. So what I can do is because I have a loop, update ping position here, set position. I can actually interpret this. We'll go constant from the current, which is just get position, to the target, which is this output. We use delta time in, oh, delta seconds. And then the interp speed will just try 10. That might make it a little bit less snappy. Apparently that was a terrible idea. Let's try like 50. Try interp. Let's just try interp 2. I like to use constant because then it doesn't slow down as it gets closer. Let's just try 10 here. Yeah, so you can see now as it pops, kind of looks like it's moved, but yeah, and then it's not very reactive now, so just adding extra cost, obviously. So now we have, oh god, that's just so horrible. Let's not do that. Let's just go straight in there. Boop. Okay, so let's add some animation. Different ways we could do that. I want to just do something simple just to show the concept. Basically in this ping master, kind of want a functions in here, I think. Let's just like on start and on remove, or on end, I suppose. Okay, I don't know. Let's just go with event begin play or construct in this case, and we'll say start and then end. Yeah, the way I want to do this now, so GA underscore ping. Create a ping actor here. We actually just straight destroy the actor on the ping. We need to do is somehow like more gracefully handle that, because just destroying it is wonder. Destroying it might be fine actually, because it's the ping panel that's then going to remove this ping. It's going to remove it from the viewport here, but instead what we can do is we can just say end, and then that will remove itself from the viewport. I think that might be cleaner. Okay, so let's add an animation in here. Well, actually, it's not going to work. It's not going to work because it needs to be in the child. But I do want all the code to live in here, so let's do some functions. Get start anim. Oh, start anim and get end anim. Play animation. Start animation. Okay, and on start, what we want to do is we just want to say get start anim is valid. And we shall play the animation. Or we could just do this. We could just make this cleaner for ourselves, I suppose. And not assume that every ping wants to do an animation. Let's take, yeah, we just have a start and end function. This one just happens like so. Generic, let's add an animation. Anim underscore start and anim underscore end. So for start animation, I'm just gonna, you could do this in a material, and it's a little bit better to do that when there's a lot of elements, but I think sequence animations are probably fine when we're talking about just major control here. So when a new ping occurs, I'm going to start at 0.2 scale. And I'm going to rapidly grow to 1.2 here. like that. And then for anim end, similarly, just close this out. Okay, and then just make sure that everything's defaulted. The widget has animations, but is set to never tick. The animations will not function correctly. Indeed. Might mean I'm going to do it through the material. Okay, so we do want to always make sure that we're calling parent assets. Okay, so now we just override start and end. Ping and oh no, anim end. There we go. And then I think you can set timer event. Do remove from parent here. Just say 1 second. However long this animation is. 0.5. It could be better to. It could be better to add an event and finished. Animation finished. Remove from parent. Might be a little bit cleaner. And then on the start, we'll play the other animation. Hello, it's a good practice in Unity to have like an image inside of a size box. This image is inside of a scale box, and the image size box scale box for like a responsive UI. So the size box and the scale box are going to incur a bunch of layout pass cost, basically, because I have to do it multiple times to inform it the end sort of like invalidation draw steps. It's got to draw all the layout. It's got to create all this geometry. And so when you've got those size boxes and scale boxes, if they're not invalidated in some other way, like it's got to do that. Otherwise, I'm like, whatever you need to do to get it to work, and if it's not something that's flying around the screen, then you can use invalidation to save so much of your problems, and the paint pass is just going to be the paint pass. Shouldn't be too much of an issue. Um, you do get sometimes where they start to conflict, so um, I would typically for responsive UI, if I'm looking at different icon scales, like image scales, I don't really want to res around, like res up or down the icons in runtime in the engine unless I'm doing SDFs in material that will actually look okay. Otherwise, you're going to have to stretch different. Yeah, if you're trying to make an image stretch to another resolution, like um, you're not going to have a very good time with artists. They're not going to like you very much because you're either crunching art down and you're going to get artifacts, or you're spreading art over more pixels than it was meant to be spread over. Too little butter spread over too much bread, or whatever it is, whatever it is. Um, yeah, if I'm doing responsive UI that like responds to like positions and stuff, like yeah, scale boxes, size boxes, sorry, like move things around, like do stuff with that. Hide and show elements and have them like shrink down nicely and then appear and stuff like that. I could always do a stream on that actually. I've done it. I've done some cool mission objective lists that like nicely collapse away and stuff like that. But yeah, if you're talking about like mobile to PC, um, and we're talking about like anchoring and like auto versus like fill sizing across the elements to try and make it like take up the space that makes sense. For iconography, like I'm gonna switch them depending on the platform's resolution. I'm not going to want to size and scale things around in ways that are not very robust. Um, Now, yeah, if you've got a size box wrapping an image, the image already determines its own size. So say the image is 64 by 64. You wrap it in a size box of 128, and then you tell it to spread to those. You've already immediately you didn't need the size box because the image can determine its own size. It has size. That depends what you're doing with the size box, I suppose, with the minimax stuff. Um, what else? So then, yeah, then inside a scale box, like if you're telling it to fill or any other sort of design, then it's going to be a little bit, yeah, got some trade-offs basically. Um, I've done it a bunch. Can't can't argue with that. I've definitely done that a bunch. What you've described there. Uh, Stick an image in a inside a size box, stick the size box in a scale box, and let it do its thing. It seems a bit weird. Um, I wouldn't necessarily do it these days. Might do something else. Might do it a different way. Why is this giving me an error? It doesn't tick. Sure. Okay. Class settings. Can I make it tick? It's good. I guess it wants to tick. Well, let's find out. Let's find out what happens. Bam. Yeah, it doesn't tick, so I can't do the animation. That's fine. Can I please change your tick configuration? Tick. Allow some ticking. Bam. 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 That's quite nice. The um the remove one is way too slow. So let's go and play with this remove animation. Let's make this way bigger and way quicker. Okay. So it's looking pretty cool. Let's make a new one. So let's do with distance. Let's go in here, wrap with horizontal box. Let's get some text in here. Let's do 220 meters. Get this to be centered. Let's do a little bit of padding from the left. Let's give this some shadow, because otherwise we're not always going to be able to read what it says. So we'll go 1.5. Let's check that out. Should be okay. Okay, so now it's as easy as updating the data and just saying, hey, just use the distance one, please. Now, let's stick this on something white. Yeah, and I can still read it all, so that's good. The number is massive, so maybe let's scale this down a bit. What font size we got here? That's way too much. Let's go 16. 16 centered. Yeah, if you're going to swap the size of an element depending on the platform, like if you're good, just change the image so that it takes up it's an image developed at the right size for that platform. I don't know. What else? So tend to try and keep things like using materials is a really great way of doing this. So keep things in borders and things like that, or generic shapes like panels and stuff. But then developing it all at 1920 by 1080, right? So for PC, and it's 16 by 9 ratio. So you've got like there's some DPI involved in that. where you can kind of get away with using that high res asset on a lot of devices and let it just draw it as pixel resolution and then just like move it around within a panel that is capable of rendering, thicker strokes and things like that programmatically. Like this thing here, I want to recreate this in a material where I can actually bring all these corners in, like a predator icon or something. It'd be really cool. Um, yeah, that would be pretty cool. Okay, so problem now is despite having, yeah, I should probably change a few things here. Despite having this text in here, text block distance, these widgets have no concept right now of what they have the ping data, but they don't have the ping component. So I'm going to add the ping component to this. I wish I was using MVVM. Okay, so we got the ping component, we got the ping data. We technically don't need the ping data now. Well, we could derive it from the ping component basically. Get data, which is less references. So I'm actually going to delete this. Bonk. And then in ping generic, it's going to have a little bit of a problem because it's like, hey, I don't remember, I don't know what this is. So we'll just do this. And then I'm going to need to do the same fix in my distance one. Okay, cool. What's the problem? Ping master. Yeah, I should have validated that. That one. Okay. And then in the ping panel, when we on ping added here, got ping data. Now, instead, we should the ping master ping component. Let's go expose on spawn. Instance editable there. Brush this. Now we get the ping component instead. So we'll take that ping comp, we'll plug that in instead, and that gives us a little bit better context. If I was using it, I'd really want to use MVVM for this, but we're not going to. It's kind of overkill. Is it overkill? It's not. I prefer to not run all the code. I might convert this to MVVM in the future. Okay, so we have now something that we can actually update. So let's go here, update distance. Let's get the ping comp, world location, distance, get camera location, get camera management, get player camera manager, get world location or cam location, get camera location, get the distance between those two. This is in Unreal units, so you're going to need to divide this by 100 in order to get meters, and then we can convert this to text from a float, and we can say that we do want grouping, and I want a minimum of 2 digits, and then we'll get this text block distance here. We'll just set text, format this so that we can say it's dist and then m. Plug that in. It's the update distance function. In the tick now, we can just call update distance. Should, Bob. Yeah, we're getting we're getting some stuff we don't want. we're getting all those extra numbers. So here we can just say maximum fractional digits 0. I don't want those fractional digits. Okay, so the next thing, let's have a look here. What have we got now? We've got ping screen edge logic. We've got a distance ping. We don't have lifetime. So what we can do is in our ping actor that we have, we can just literally set the lifetime to 30. And to represent this a little bit better and just test this really quickly, it should remove gracefully, or at least the animation will play. Distance won't be happy because the ping component doesn't exist anymore. So just make sure that this is a thing, and then set text here to no text. All right, one more time. Bam, bam, bam. Cool. And obviously that's going to be 30 seconds. 30 seconds seems reasonable. Okay, so we've got ping lifetime. Cancel ping. All right. So, cancelling the ping. this is going to be annoying. There's different ways you can do it, but basically all you're doing is you're saying, is my dot product within range of one of these pings, and whichever one it is, then that's the one that I care about, and that's the one I'm going to remove. I'm going to do that from the HUD marker manager. So let's close everything down, and we'll open up the. We've got 15 minutes to do that. I think will be enough for today. So let's open up the ping manager, and we'll put a little tick in here. Now I need to decide my functions. So we basically need to change the state of a ping to say like that it's being looked at by its owner locally. That's just a UI data. So I could have the manager store the best one that you're, or the one at least if you're looking at one, and then I could have the HUD panel which holds all the registered. Now I'm going to do it from here, and then you're going to have an ability when you middle click that checks like what's the best one. The thing about doing, I can store which is the best ping you're looking at, but I don't have any context here of widgets in this ping manager because that's part of the panel. Although the logic would say I should really move all of that to this ping manager and then have an MVVM that comes out of this ping manager, and the panel just listens to it. But it's a little bit overkill for the amount of time I've got, so I need to make this decision really quickly. I need an update in the panel that basically says is looking at a marker, right, or a ping. So let's say get highlighted ping, and then so what we do is we say for each ping get camera manager, get rotation, get forward. Actually, we could just get the forward vector. There we go. And then dot product to that with the direction get world location, direction from the camera to the asset. And then what this is going to do is give me something that I can compare against and say, hey, if this is more than or equal to, and we'll just say like 0.98 for now. Hello, 0.98. Okay. If that's valid, then we'll return that ping. Highlight ping. We'll just get highlight ping. That one. If we reach the end, we're not at 0.98, which basically means a dot product that's like facing down the same vector, and we're not. So, or at least we get to the end here and we say, hey, didn't happen. Not looking directly at any pings. Nothing needs to be highlighted. Okay. Now in our UI, in our ping panel, we should already have a tick in here that's doing update ping position. So we'll make a new function, update highlight ping. What I'm going to need to do is on construct, when we init the ping panel, is I'm going to save this manager as a reference, which will be nice if I ever move this to MVVM, because I will definitely be using that as the resolver. Okay, I'm going to move this out of the way. I'm going to clean some of this up now that I have a reference here. I'm just going to move everything to this except this. So that's just control, click and drag. Clean that up, get the pings here, bring this down, bring these over, and now this graph looks a little bit cleaner as well. Awesome, nice little clean graph. Now we have that ping manager. So in this update ping positions, update highlight ping, or ping high, I should call this update ping highlight. Update ping highlight. Are we highlighting any particular ping? So in here, we get that manager, assuming it's valid. Get highlight ping. If that's valid, then we do something to it. We're going to actually promote to a variable here. Last highlight. What we want to do is, if this is not equal to the last highlight ping, and if the last highlight ping is valid, then we want to disable the highlight on this last highlight ping, as long as they're not equal, right? And then let's do L new highlight. Okay, so L new highlight. If there's a new highlight, then, oh sorry, if the highlight is different. The interesting thing is this can come out. In fact, I would do this. I don't even care if it's not valid. This is allowed to be a null pointer, because nothing is different to something, therefore update. And if there was something, change. It's different, right? So we're unhighlighting here, and then we're asking if the new highlight ping is valid, and if it is, we're turning it on, and that should be the function. That should be it. I just need to add the actual highlight event. So in the ping master, we'll say set highlight as a function, set highlight, and that'll take a bool, highlight. Cool. Back in the ping panel, set highlight. Yes, right. Okay, so we have the ping map. come in and find the related widget. Set the highlight on it. In this case, we're setting this one to true, and we're setting this one to false. And then I just need to decide what that means. So we're currently using the distance one. So let's highlight this guy. We'll take this image and we'll actually colorize it. So override, set highlight. Why? Did I do it wrong? You're not a private function. So what's your problem? Yeah, an event set highlight. Okay, it's not a function, despite being a function. What if I had a return? How about now? Are you a function now? Set highlight. Fine, whatever. Event set highlight. And then in here, I'm just going to say image ping set color. Whoops. This is just a really. This isn't maybe how I would do this because the ping itself may be colorized and often will be. But okay, so if it's highlighted, we'll go look at orange, and if not, we'll just stay white. Let's see if that works. Whoa. I may not have called. No, I did. Am I like. Why? Yeah, one of the problems with this is that when you tap it, because the widget takes up this much space, the center of it is not where you think it is. You would want to look at this item. Let's go and change the ping with distance to resolve that. So right now we have a horizontal box that puts some text on the right. We can't just move this horizontal box. Oh, again, am I wrong? No, I am wrong because the size of this is going to change a bunch. We want that center to be to be relevant. So we're going to use an overlay instead. And as we use this overlay, we could just offset this text as long as this text is. So we could go from the left here and just say 40. Ah, you son of a gun. We would not be using padding because that actually changes the widget's geometry. We could wrap this in a visual attachment, so it does nothing to the shape, and we can set the Y to 0.5, and we could move this outside the image. There we go. So now when we ping, whoa, got rocket launcher. So now when we ping, the ping is actually on, which is cool. So why am I not getting? So yeah, now we just need to debug. Get highlight ping, please. Oh, the debug mode failed. Of course. Ping here. So look, update ping. Debug mode failed. Kidding me. Okay, get highlight pings. Let's do a print here. It's probably just the fact that this dot product is the wrong way around as usual. No, it's point. What's going on? It's bizarre. I've done something. I've done something drastically wrong. Ping component. Get the world location. Get the distance of camera managers. Get the unit direction from the forward vector. That's hilarious. Get actor location. Then get the dot product between the forward, between these two. It's up a bit. Right that. Bam. Yeah, it's yellow. It's immediately yellow. That's annoying. We're incapable of setting the highlight to false, apparently. Let's never return a highlight ping. Let's just check. 0.9. That's 0.98. So that's way too close. 0.995. Let's try that. Bam. 0.9. Yeah, so this is actually still valid. That's still valid. 995 there. 999. 99. Okay. 9. Still 99998. Yeah, it's good enough. I mean, it's somewhere within that circle, so that's pretty cool. Okay, bam, bam, bam. I don't know why it would be setting that over and over, but apparently it is. Oh, I know why. I never set last ping highlight. So last ping highlight false, and last ping highlight here becomes like that. Bam. Cool. So now you get the highlight. Boom, boom, boom. So the idea of this will be I can create a cancel event where if I press the button, the UI matches with the game view, the game code. Basically, the ping cancel will occur. I'm not going to do that today because we're at time. We're at 2 hours. But that was pretty cool. We got 1, 2, 3. Got some little animations. Got some little removals going on, and a highlight that's going to allow us to cancel that. I might come back. I might come back after lunch and finish more of this because I think this is a cool little. Boop, 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 boop. You can actually get more on screen than 3, which is pretty fun. Also, I've noticed that when I cancel, they're actually sticky. Anyway, very cool. UX is fine. I've been Ren. Thanks for joining. Hopefully that was of interest, and see you in the next one. We'll build out the whole idea of this gym, by the way, is that I'm going to put a little tutorial on here that tells you how to do pings, and this is where you can sort of look at that, and you'll have like contextual pings down here. Let's do ping. Change this ping highlight. Yeah. Cool. That was my checklist, by the way, for anyone listening. Okay, thanks very much for joining. I'll see you in the next one.